showing, again, it's a little bit different than that original DNA microarray that I showed, but so now it's just flipped on its side. It's showing chromosome 8 in a cartoon version, and it's showing right here in red where we have a deletion on the chromosome. So there's missing material on the chromosome. And then this is showing here when there's a mistake in actually the letters that make up the DNA in a specific gene. So why is all of that important? I can talk about genetics and what it all means and how we look at it, but there is a reason why it's important for all of us in the room. It's because we know of some genetic causes of congenital diaphragmatic hernia. We know about, if we looked at all cases of congenital diaphragmatic hernia with our current testing abilities, about 20% of the time we would find some type of genetic cause by doing the tests that we have available. That doesn't mean that the other 80% don't have a genetic cause. As geneticists, we think that there's probably a genetic cause to nearly every case of congenital diaphragmatic hernia. It just means that we don't have the sensitivity. Our tests are not good enough yet to detect all those causes, and that's why we're here, because we're trying to develop additional tests that would give us more information about what is causing congenital diaphragmatic hernia, which in turn we would want to use to develop better treatment, prognosis, and just identifying. So here is just a brief overview of a couple different types of causes of congenital diaphragmatic hernia that we can detect by chromosome analysis. And just to let you know that all of these cases here are actually conditions where if the child has a congenital diaphragmatic hernia, they typically have other birth defects as well. So they have heart defects, they have structural defects. These kids typically don't do very well, unfortunately, because they have all of that extra genetic information. And not every single case, so we're looking at a trisomy 13, a trisomy 21, a trisomy 18. And trisomy just means that we have 3 copies rather than 2 copies. And many of you probably heard, if you had your diagnosis during your pregnancy, someone might have said these different things to you, talked about doing an amniocentesis, because a congenital diaphragmatic hernia is associated with these, but not every case of these conditions actually has, not every child with this condition actually has a diaphragmatic hernia. It's just if you take every child with trisomy 13 compared to the general population, more children with trisomy 13 have a congenital diaphragmatic hernia than children in the general population, but that doesn't mean that every single child does. And again, these only account for about 10% of cases of CDH. And so there's a lot of children with CDH who don't have this, but it's one of, I mean, I think why it's talked about so much is because it's one of the things that we can detect, and we can provide families with more information about what it means for their child to have one of these particular chromosome anomalies. We know of other children with these chromosome anomalies, and we know, unfortunately, that many children, especially with the trisomy 13 and 18, don't do very well because they have so many other problems. This picture here is now taken all of our chromosomes and put them into the cartoon drawings that we've seen before on the other slides. And what it is showing is it's actually showing just the diversity of the genetics that we know of congenital diaphragmatic hernia, meaning that there are so many chromosomes that have been associated with the congenital diaphragmatic hernia. So these are excellent researchers, it's not us, I'll have to tell you that, that have looked at cases of CDH, so children with CDH, and done the DNA microarray. So they're looking for these microdeletions and duplications. And what you see there is next to each of the chromosomes, they put what they have found. And this is not done by one group of researchers, but it's what's called a meta-analysis, means that they took all the information that was done by many, many researchers all over the world and put it all together into what do we know at this point. A red bar means that that region of the chromosome has been duplicated, or there's been 2 copies present in an individual with congenital diaphragmatic hernia, which we think caused them to have the problem. A green bar means that it's been deleted, and a blue bar means that it's been translocated. And I'm not going to go too much into that, but it just means that it's been in the wrong position in the genetic information. But what this is showing, and I think is a really important point to take home from this slide, is not, what are all of these deletions and duplications, because I mean, it's important what you know and where, it's important you know where it's at for your individual child, but what it's showing is just the complexity of the genetics of congenital diaphragmatic hernia. So if we think of other conditions that we think classically being genetic, I don't know if anybody in the room has heard of cystic fibrosis. Okay, So cystic fibrosis, if I put up a picture like this, it would not look like this at all for cystic fibrosis. I have to put up a picture of one chromosome and one gene. There's one genetic cause, and we can look at, any child with cystic fibrosis, I can do a test, a very simple test, and identify what it is and give them more information about their child, about their health, and what aspects they need to follow in terms of with their doctors. Whereas with the congenital diaphragmatic hernia, there's so many places I have to look, and even when I'm done looking at all those places, 80% of the time, I still don't understand why the congenital diaphragmatic hernia occurred. And so one of the things that we know is we need to study a lot of children with the congenital diaphragmatic hernia before we become even close to understanding the genetics of it. Because so many kids are, we already know some kids are unique, but they're also unique in what actually caused them to have the congenital diaphragmatic hernia. The other thing I wanted to go into a little bit is patterns of inheritance. So understanding something can be genetic and can be de novo in the family or new, and something can be genetic or inherited in the family, and how this is important to this group in the room. So for most individuals, it's that picture there that represents their family, meaning that I have circles for girls, squares for boys, and then we just start looking at how it so this is mom and dad. These are their 3 children. They have 2 boys and a girl. This is mom's sister here and her children, dad's brother and her children, and the grandparents up there. And this is called a pedigree. The individual in blue is showing the child who's been affected with the congenital diaphragmatic hernia. And the majority of families with a congenital diaphragmatic hernia look like this, meaning that there's only one child, and if I stretch this way back and I asked about grandparents, brothers and sisters, and I asked about paternal grandparents, brothers and sisters, and say, there's nobody else. Yes, maybe there's been some other individuals who have been born with a birth defect, but there's no one else with a congenital diaphragmatic hernia. And what we think for these families, for the majority of these families, is that that child with a congenital diaphragmatic hernia, it's something new that occurred in their genetic information. And we all have new things that occur in our genetic information. Each and every one of us, when that egg and the sperm came together, little changes happen. And for some children, they occur in more important spots than others, and that's what we think. For the majority of kids with congenital diaphragmatic hernia, something new that happened in their genetic information. That is a naturally occurring process in all of us. But we also sometimes see families like this, meaning that we see there's no one else in history but a family who's had 2 children affected with the congenital diaphragmatic hernia. And it's possible for these families that mom and dad are each carriers of something. And what it means to be a carrier is that you yourself have some type of genetic change that doesn't cause you any problems, but in combination with a similar genetic change in your husband, and you both pass down that genetic change, it can cause a child to be affected with the congenital diaphragmatic hernia. This is something called autosomal recessive inheritance. I'm not going to go into that in detail today. I can talk more about it, but things like cystic fibrosis are caused by autosomal recessive inheritance, just to give you an example. Some families also look like this, meaning that neither one of the parents have anything, but if I ask farther back and say, oh yes, I did, I had a brother who, many years ago, unfortunately in these families, I most often hear that if they're kind of an older family, I hear that unfortunately the brother passed away at a very young age from his congenital diaphragmatic hernia, and now they have a child affected with a congenital diaphragmatic hernia. And this is something, again, where we think it's something not de novo or new in that child, but something inherited.